For those who don't know me, I'm Alexander Michaud. I'm the president of Yale Boston. This is a collaboration between Yale Boston and the Yale Club of Los Angeles. And I'm just here mostly to introduce our moderators, Fred Isbell of the Yale Club of Boston as well. He's our events co-chair, and Kevin Mark Lodi, the co-president of the Yale Club of Los Angeles. Now, Fred is a research manager with IDC for the CMO advisory service practice. He's a high technology industry marketing veteran with B2B marketing experience spanning companies such as SAP, Compaq, Digital Equipment Corporation, Wolters Kluwer, and Information Resources. And Fred has economics and political science from Yale, as well as an MBA in marketing and strategic planning from the Duke Fuqua, I hope I'm getting that right, Fred, I apologize, School of Business.
Nailed it.
Okay, great. And he also holds executive certificates from the UVA Darden School of Business Managing and Leading Innovation. He is a digital marketing and data-driven marketing guru. Kevin Mark Lodi is a management consultant. He advises on venture growth and service innovation in several fields, including finance, healthcare, media, real estate, and many others. Recently, he was part of a team spearheading Yale Smilow Cancer Hospital's first hospital-at-home platform in partnership with Medically Home. He also teaches strategy and design thinking and sits on the advisory board of the University of California Design Thinking Program. He received a BA as well from Yale in humanities and an interdisciplinary MS/MBA from Dartmouth's Tuck School of Business and Geisel School of Medicine. So without further ado, our agenda today, Kevin is going to make some introductory remarks just about the topic, and our guest, who is Dr. Jobst Landgrebe. Dr. Landgrebe will make his presentation on ChatGPT and AI, and the majority of the event will be open for Q&A, moderated by Fred and Kevin. So again, please reserve your questions for the Q&A. We're scheduled for an hour, but we have some flexibility, so we may go as long as an hour and a half. So Kevin, please take it away.
Thanks, Alexander, and thanks to each of you for joining us for today's event, ChatGPT and Other Random Acts of Digital. To frame the subject, in the past year, discussions concerning digital transformation and artificial intelligence have proliferated well beyond the realms of academia, consulting, and business operations. The news media, online search, the blogosphere, every channel in the mainstream is talking about these transformative practices and technologies. ChatGPT is unquestionably the latest AI solution to go completely viral. You'd have to have been living under a rock to not encounter a friend, a colleague, a guy on the street who hasn't run some experiment with ChatGPT. The popular claim is that ChatGPT has mastered the domain of language, including text generation and dialogue generation, and that it does so on demand in a matter of seconds. Since its release last November, millions of users of every stripe have experimented with the platform, and its output has generated awe, as well as concern, and of course, unbridled hype, both positive and negative. So what is ChatGPT? ChatGPT is what's called a large language model, or LLM. You may have also heard of Google's Bard or Meta's Galactica. They are also large language models. So large language models, or LLM, are part of the third wave of AI that began in 2012 with Google's successful use of deep neural networks, which are a form of machine learning that's stochastic in nature and requires training on massive volumes of data. In the case of ChatGPT, the learning model was trained on over 570 gigabytes of data so far. A model this powerful can clearly disrupt the status quo. But in what ways does it create value? What role can it play, should it play, as a practical tool capable of powering meaningful improvements in commerce, the arts and sciences, and in life as we know it? And when we consider the more macro movement toward digitization, how do ChatGPT and other AI innovations relate to and serve the objectives and infrastructure of strategic digital transformation? These are the questions we'll address in today's session. And with that, I'll turn it over to you, Fred, to introduce our special guest, Dr. Jobst Landgrebe.
Thank you, Kevin. I'm thrilled to introduce Jobst Landgrebe. Jobst is a physician, a biochemist, and a mathematician. He's a true polymath. His formal education in science began when he was a teenager. At the same time, he was trained in classical philosophy by his grandfather, Ludwig Landgrebe, a well-known German philosopher. He obtained his MD in 1998 and a PhD in cell biology in 1998 as well. Since then, he has worked in neurogenetics and biomathematics at the Max Planck Institute in Munich and the DFG Center for Cell Biology in Göttingen. For the past 25 years, he's been in active research in the fields of artificial intelligence, the theory of AI, and the theory of physics. In the mid-2000s, he developed a new model for lipid recycling and distribution in the mammalian liver. In the 2010s, he engineered a new algorithm for natural language interpretation in restricted contexts. And he's currently developing a new interpretation of quantum mechanics and working on a philosophy of matter. His firm Cognetic advises on both the science and economic viability of data science, based operations and services in several domains, including professional services, biotechnology, and healthcare. Jobst, a very warm welcome from the Yale Club and the Yale community. Take it away.
Thanks a lot for inviting me and for the warm words you gave me. And I'm excited to be able to talk to you. So let's start with what are large language models. We will see this in a minute. What are they? Then how we will learn how they work, what they can achieve. And then we'll also, to wrap it up from a business perspective, look at artificial intelligence versus digitization. And we will see that for most companies, it's still about more about digitization than about AI. But first, let's start with the large language models. A large language model is a special type of neural network-based natural language processing algorithm. It serves the managing of language with a computer. And these models are obtained by generating huge language distributions called foundational models. And this is done with unsupervised training. What this is, we'll see in a minute. The process requires huge amounts of data and billions of investment into annotators and computing power. So, for example, one single run-through for GPT-3, which is the foundation of ChatGPT, costs $1.5 million in CPU time. And that takes into account, the costs of renting those CPUs or buying and running them oneself. And so if you use so much computing power, it actually doesn't matter whether you rent or buy. It's then quite similar. It's so one single run, but you need hundreds of runs to get the model finished and to refine it. So the computational costs are in the hundreds of millions alone, and then that doesn't take into account the human annotators. So here you see an overview of large language models. They can be used for text generation, for text classification, for knowledge answering, question answering, translation and dialogue generation. And here you see many of the main players. Meta is a big player in this area. Google is a big player. And of course, OpenAI is aware with ChatGPT. So these are extremely big models. And here are the three main competitors in the large language model race. So OpenAI, which is co-owned by Microsoft now, which bought shares in OpenAI, and which plans to integrate ChatGPT into Bing. This is perceived as an AI breakthrough, despite the hallucinations of the model. What an hallucination is, we will see a little later, but it means that the model is creating pseudo-facts that are not true. The market expectations are huge. Right now, OpenAI has a valuation of $30 billion. Microsoft is investing billions and integrating GPT into Bing. What about Google Bard? So Google, we will see a bit later, is the inventor of the technology underlying all these models, the transformer approach. And when they presented Bard a couple of weeks ago in an investor meeting on the web, it produced a minor hallucination about the James Webb Space Telescope. It attributed something to the telescope which it hadn't done. It was really minor. It was not a big thing, but it created a hysterical reaction on the markets, and Google or Alphabet lost $100 million of market capitalization immediately. I think they've recovered now, but it just shows how hyped this whole area is. And Bard will be integrated in Google search, nevertheless, and quite certain. And as we will see later, it will change the way we do internet search. And then what about Meta? Meta has launched Galactica in December, a bit before ChatGPT was launched. It was perceived as a total failure due to the hallucinations, because in the scientific domain, pseudo-facts are, of course, unacceptable. It was immediately rejected. Douglas R. Hofstetter wrote that it's like great Italian food served with dog crap mixed in, and it had to be shut off. They shut it off. They now said at Meta that they are backing off conversational AI, but I'm certain they are preparing a comeback because the competition is fierce and it's just too commercially attractive. But what you can learn from this story is that though all of the 3 large language models I've shown here has a similar performance, the public perception valuation are totally different and are basically a matter of spin and contextualization. And the reason for this is that the hype is so big. And when you have areas which are so overhyped, then spin becomes very, very important. And so that explains why the models are perceived so differently, though their capabilities are very comparable. Now, McKinsey now calls these models generative. It makes huge claims about what they can achieve. That's a misnomer, as we will see. And here I'm showing you a recent paper about ChatGPT by McKinsey with a lot of claims what could be done with it. So these are example use cases. And you see that on this one here, there's not a single one that's valid. One that is valid, but not specific to the type of model that we discussed today. So you can do this with classical conventional networks as well. And most of them have only very limited benefit. Yes, there's some benefit, but it's not as big as McKinsey claims. And 3 of them actually won't work. So these are completely hot air. So they are, if you know how the models really work, then it's clear that they won't do this properly.
So in other words, Jobst, if I can jump in what way is it a misnomer?
Because the models can't generate new content. They can only draw on the distribution they were used to be trained, and then basically assemble texts that are based on this distribution, but they can't generate anything not new. And so they are sequence generating models and not generative models. I mean, you can call them generative models because they create something, but you can also call your pocket calculator generative, because if you press 3 + 2 =, you get 5. So it has generated, hooray, a 5. But that's what basically this model does. It's just much more complicated, but it doesn't create anything new. And so therefore, I think generative is the wrong name. Now, if you look at some other use cases, the really most important one that McKinsey has identified, and which is the reason why OpenAI is so highly evaluated now, is search and question answering. Because here it says on companies' private knowledge, but basically what's really interested is the internet search and advertisement. And I think that the introduction of these large language models will completely revolutionize the way we are doing this today. And so this is the most important use case that's driving the valuation. And who basically is first to use these sequential language models in search will basically have a similar effect that Google had in the 2000s, when it was the best search engine. Everybody wanted to search with Google and all the advertisements went to Google, or a lot of them. And so this will happen as well, and that's why the fight is on. Here you see again that many use cases that are possible with AI are misclassified by McKinsey as being LLM specific, though they are not. So overall, this picture here doesn't look so favorable for the LLMs, right? A lot of yellow, some red, very little bit of green. So what is really their attractiveness and what can they really do? So why is the utility, in other words, of these models beyond search quite limited? And I want to highlight, before I move on, the most important use case that everybody sees is generation of text on demand, like write me a cancellation letter, make me this plan or that plan. And all of this is quite okay, what you get when you ask ChatGPT to do this, but it doesn't go beyond a template-based approach. So very classical that you have kind of a template in Word for a text where you leave some blanks and then you open the template and fill in the gaps. And it's not much more what it's doing. So, and that's quite, and plus it's making mistakes, as we will see. So that's why I mean it's limited. Now, we have to understand a bit how LLMs work and what they can achieve. So here I'm showing you artificial intelligence on a coaster. So basically artificial intelligence is just applied mathematics for the identification of or mapping of recurring patterns into machines. It's really only for recurring patterns. It's not a model of the human mind or even of animal intelligence. So AI does neither think nor intend anything. And there are two flavors of AI. There's deterministic AI and stochastic AI. Deterministic AI is based on rules, search, logic, and trees. It's explainable and reliable. It's what got used in Deep Blue, the famous computer that beat the Russian chess champions in 1997. Stochastic AI is based on regression, classification, and pattern recognition. It's not explainable, it's probabilistic, and it's built into AlphaGo and also ChatGPT. Although ChatGPT is a hybrid model because it also contains deterministic components, as we'll see in a bit. And these are the so-called deep neural networks that have been so hyped over the last 10 years. Basically, how does AI work? So today, most people see it as a statistical learning for automation and pattern identification purposes. So you have a input data and output data. And what you do is that you compute a relation between input and output. And so, for example, here as input, you might have, that's a very classical application, email texts. And as output, you have the emails marked as spam or not. And so the spam filter is a classic example of an AI algorithm which learns from the tuples of the form input, output, which messages are spam and which are not. So here you see how this looks. So you have, for each, you have millions of these tuples or billions where you have an email plus an indication whether it's spam or not. And then the model can learn the relationship between the email text and other properties of the email and it being spam or not. So this is done by minimizing a loss function with numerical optimization procedures. That's really important. So that's the core of statistical learning, are just numerical optimization procedures to find a minimum of the loss between the real outcome and what the model predicts. And so now what's interesting about chatbots like ChatGPT or Bard is that they are trained in a different way. So they don't learn with a classical outcome, like here, where you have an input-output relationship, but they learn without outcome. So what they do is you feed them huge sequences of text, and the model gets the task of produce the same text it received, but by encoding and decoding it. So you force the model to encode the language it receives in a mathematically different form that varies from the input, but to recreate out of this the output. And by doing this, you are parameterizing the model with millions or hundreds of millions of parameters. And these parameters basically model language as a condition probability. So language is modeled like a distribution, not like a Gaussian distribution, but as a very complicated multivariate distribution. That's the foundation. So the foundation is done without outcome. And that's super important because if you would need an outcome to do this, it would be unfeasible because you have so many data. So that's very important that you can train the basic foundational model without any outcome. And then the second step now is very interesting. Now you have to specify the model to become more specific to the task at hand with supervised training. And what was done here for ChatGPT and what's also done for the other models is that annotators, thousands of annotators, they receive questions from a database of frequently asked questions or frequently requested tasks, like write me a poem, what is a cookie recipe for tomato soup, can you write me a cancellation letter, and so on. And they provide answers to these questions. They do it by hand. Then you get tuples like the ones we had before, like the tuple here. Right now you have something question and answer, or task and solution. And these tuples are taken and they are now put into the model, and the model is asked to be trained on these examples. And this changes the parameterization of the entire foundational model to something that is more what you would like to have in an application like ChatGPT. So what will be able to answer your questions and what will also be able to fulfill some tasks. And then it's the next very important step is that now the system is getting questions and gives answers, which are, and the behavior was trained using the examples created here. But now there's still a trainer, but this trainer now doesn't give the answer, it just scores the answer given by the model. And from these scores, a reward model is derived. And the reward model basically is a model that gives automatically a certain quality indicator to an answer or solution to a task that the model has created. Now comes the super important step, which is which is basically an invention of OpenAI, which they invented 5 or 6 years ago, and which is the technical foundation of their fame. So that's something that Google didn't do. That's now you can use this artificial reward model to automatically train the model. So now the model can get new questions, create answers, and rate itself, because it has learned a very basic way of rating. So this is easier in games like chess or Go, where you have a natural way of giving reward points. So if you get, if you capture stones of the opponent in Go, you get a point. So that's easier to model mathematically. Here, the quality of the answers was rated by hundreds of thousands of ratings, and a rating model is derived. And this is the most important thing to understand, because this explains why the model can really perform a lot of tasks, but also why it's so bland and why it's also, anodyne in the way it answers questions and repetitive. Because, of course, the reward model can't mimic the true rewards that humans give to each other when they have conversations, because it's very schematic, right? You're deriving a mathematical reward model from a few 10,000 or 100,000 ratings given by humans, but that's, of course, not the same as a real rating of a real of a differentiated rating of that's happening in a conversation. When you feel that something that your conversation partner says is appealing. And so basically, this is the secret why that makes ChatGPT so successful, but that is also limiting it. And now, what properties does this machine get from the way it's trained? So it can create plausible answers. So it gives relatively plausible stochastic answers to frequently asked questions. It performs standard tasks quite well, though the results need to be checked. We will see in a minute why. It has a very good syntax. It almost never makes syntactic errors. That shows you how super efficient the transformer architecture in the first step of the training is, the step that establishes the language model. This is super impressive. When I think of, I'm now looking at 25 years of artificial intelligence and natural language processing I've witnessed. This is a huge advancement. But often the output is not factual, so it can create pseudo-facts, which are called hallucinations. That's also a misnomer, of course, because a machine can't hallucinate, which are intermingled with implausible texts. And the density of the error increases outside the core distribution of the training. So in features and contents that occur often in the internet, they are learned well. For these, the intensity of pseudo-facts is low. But when you get into fringe topics like Egyptology or 15th century English novels or poetry, it gets, implausible, because it has not enough material to be trained properly. Also, the answers to complex topics are often generic, repetitive, bland, vacuous, and anodyne. That has to do with the scoring system that we learned in the previous slide, because the scoring system is so schematic, but the model depends on applying the scoring system during this automatic training step in the last training. That's why it explains this, flatness of the output. I already said it's failing in fringe and demanding domains such as philosophy or science. It has a limited ability for dialogue, which is achieved by entering the previous conversation to some extent. And this is super interesting because that's also how you can fool the model. And we will get back to this a bit later. It doesn't, of course, understand what it does. It's just generating a chain of tokens as conditional probability. So you shouldn't think that this is just a reckoning recipe that is running in the model. It's a very, very long equation with millions of parameters, but basically the model is just calculating the most probable sequence given the previous sequence. That's all it does. So it doesn't really, do anything more. Here, when you are in the middle of the distribution that was used for training, you get good quality. When you are outside of it, the quality is lower catastrophic. And that has to do with the way it is trained, which we saw. Now comes, I think, the most important part. So ChatGPT has been trained so well that you cannot make it say certain things. So it will never say the N-word. It will not use openly vulgar language and so on. And why is this so? One open question about it is whether it is an end-to-end model or has a controller architecture. And OpenAI doesn't publish this, but I think it's a controller architecture, because only with a controller architecture you can achieve this moderation, what they call moderation, which means that the bot doesn't generate adverse text about sex, race, or unpolitically correct language. And this is because the controller filters the questions and then invokes certain parts of the model or suppresses certain answers to make sure that the model doesn't react in the wrong way. However,
Jobst, could I jump in quickly?
Yes, please.
One of our people asked if you could define, and I believe he's interested in having you define end-to-end model versus controlling architecture.
So an end-to-end, yeah, very good question. So an end-to-end model means that you have one single huge model and you give it an input. It has an interface to give an input and it gives you an output, and everything is computed from this one huge equation. And this is the dream of a big group within the AI community to do everything like this. And there's another camp who wants to use controller architectures. I belong to the second camp because we believe it's better to have separation of concerns in such a complicated software and to have a controller that basically is used, trained, or somehow configured to invoke then the specialized modules. And given the behavior of ChatGPT, I think it must be a controller architecture where basically behind the interface sits a controller which looks at the input and decides what to do next. That will invoke the moderation module to present, for example, hate speech and so on. It's also very important because we don't know why the model can generate code. So I don't think that it's an end-to-end model because then it could not generate language and code. So OpenAI also has made Codex, which is a large language model exclusively trained on code, which can produce syntactically very high quality computer code in many important programming languages. And I think what they've done is that when you ask a question, when you ask it to generate code, the controller recognizes this and then doesn't invoke GPT 3.5, which is a language model, but invokes Codex. And now what is super interesting is that when people conduct very long conversations with ChatGPT, they can make it create harmful, what is called harmful content. So they can make it say, you should suicide yourself, which is of course not something that the creators want. How is this possible? I mean, they've put so much effort into making this model politically correct and, you know, modern and woke. And I'm using this just as descriptive terms. I mean, the model is, if you talk to it, it's perfectly politically correct. How does it happen that despite all this effort, it's creating adverse output? And I think it happens because with the message shown here, you can't train it to conduct longer dialogues because there are so many possibilities how a dialogue can evolve that in those steps where you involve human beings, which are steps 2 and 3, you can only have question, answer, or task solution tuples, but you can't have tuples that result from long dialogue. So if you give the model longer dialogue to make it behave in a dialogue fashion, what then happens is that you unravel parts of this distribution that are not under control of the moderation effort I've just shown you. This is super interesting because what I think will happen is that the creators of such models will basically restrict the number of iterations you can have with the model, because mathematically it's impossible to control what happens if you have a dialogue and at each step you give all the previous steps of the dialogue to the model again to make it create its output so that you can somehow mimic an awareness of what happened before. And that's why they have to do it, to make the model more context sensitive. But the price is that uncontrolled things happen with the model, which you can't, you know, manipulate during training time. This is super interesting and mathematically speaking, the most exciting aspect, and also practically speaking, because it severely limits what you can use these models for. They are great at question answering, information retrieval, task solving, but dialogues with them are dangerous and will remain dangerous. There were also really severe bad outputs that Bing now created, which has integrated ChatGPT. So it is really very interesting. Now, I just briefly want to show you this, put this in context with general digitization strategy. So in artificial intelligence, that's an applied science for pattern identification and the automation of repetitive processes. It requires a lot of data, and many companies can only get marginal benefits from AI because they lack repetitive processes or they do not have enough data. Only the giants of the digital age have enough data in a native way. But digitization is the modeling of a company's business processes in a structured and machine processable form. Every company can do this. And so this enables business process automation. It's also process measurement and control, and also BI based on the resulting data, and also continuous process optimization and so on. The overall digitization level of companies in America and Germany is still very low. So of course, Google is very digital, but many companies are not. 95% are not, or 99%. And so for most, digitization is not only more beneficial than the use of AI, but it's also the prerequisite. So they have to do digitization before they can use AI. And then once you have digitized your business or are a natively digital business, then you can use AI. So I have one example, which is very interesting from the insurance industry, how this can happen. So here you have a claims management process, which is, of course, a super important process. Every year in America, billions of claims get processed. In the health insurance industry, there are billions, but also many millions in the P&C insurance. And you see here the very high-level view of this process with an incoming claim, the coverage validation, the technical validation, the regulation, and the payment and correspondence generation. And you can see that you can map all those steps to a digital system, and then you can semi-automate or automate them. And then you can also, on top of this, if you have a digital representation of the process, you can also put a business intelligence layer on top of it. You can measure the process, you can refine it, but you can also tune and adjust it depending on the business context. And this is basically a very high-level picture, but it shows you how great things become once you have digitalized everything and then can now apply BI and AI to it. And then you get into a new world, because then a business process, a white-collar business process, becomes like an assembly line where you can parameterize the machines to act, in a regular and controllable fashion. Whereas today, this is not the case. There's a lot of human variance in these processes, because, humans you can't control human workers as much as you can control machines. So I think this is the future of many domains, that more and more of this automation will be introduced. This doesn't mean that the humans will go away. You still need humans quite a lot, but the whole setup of the process will become more regular and more reliable. Yeah, so this was what I wanted to show you. It was a bit fast at the end, but I wanted to save time for the questions, and thanks a lot for your interest.
Well, thank you, Jobst, for that very insightful presentation with very clear analysis. I think we learned a lot about large language models and also artificial intelligence in general. And the discussion concerning digitization really put things in perspective, starting with the fact that digitization is really the prerequisite to any potentially successful artificial intelligence development or integration. Well, this brings us to the Q&A part of our session today. And initially, we were going to kick things off with some starter questions. But Fred, I noticed so many great questions in chat that I'm thinking maybe we should just turn this over to audience questions.
Yeah, I was going to suggest that.
Okay, so let's start out with Alexander.
Yeah, so I wanted to forward along a question from Bryce. He wanted to know to what extent there's been attempts to quantify the frequency of and severity of these hallucinations, such that they might trigger a threshold automatically, and also whether or not some of the things that are currently being managed by the controller model, ensuring for politically correct speech, would also fall under the category of hallucination, or if that represents a different sort of concern, if it were to be captured analytically.
So let's start with the second question. So, what this moderation API does is has nothing to do with hallucination. It's really a classifier to suppress input into the model that is what they call harmful speech, and also to avoid the model giving out such speech. So this has nothing to do with hallucination. It's not perfect. So what they have in addition, they must have, because whatever you do, you can never, for example, get the machine to say the famous N-word. Yeah, you can't get it to do this, or the F word. So and why is this so? Because they have a deterministic blacklist. So not only do they have the moderation API, but they also have a blacklist so that sentences which contain these words will become suppressed. Because I looked at the paper, and the moderation API has a classification quality of 80%. So in 80% of the cases, it's able to perform the same duty that a human moderator would perform, but it fails in 20%. And they must have a deterministic way of finding the rest. Now, the first question about the hallucinations. So that there are now papers measuring them. I haven't read all of them, but it really depends on the domain. So if you are in a domain like, if you ask something about what is France or what are the United States, then you get very little hallucinations, because there's so much text about these core domains of human knowledge, or what is the tallest mountain in the world, or and how many I don't know countries are there in the world. If you ask such very basic trivial knowledge, there's almost no hallucination, because there's so much material supporting the sequence that corresponds to this knowledge. That's what all the machine knows, is the sequence. Now, if you go into areas that are more on the fringe, you get up to 80–90% hallucinations. And for the model can't suppress it, because it can't know what the hallucination is. It can only create a most likely sequence. And yes, you can let the model also give out a likelihood of the sequence along with the sequence itself. And then you can introduce a threshold to say, if the likelihood is too low, it won't give out anything. And that happens. So you can sometimes get the model to say, I don't know this, but it is very hard to fine tune. And there's no way, because the model doesn't understand what it's saying, there is no way to suppress the hallucinations. The only way is to, and what's going to happen is that people will take the raw, they will license from OpenAI the raw foundational model, and then they will train it like hell for a special domain. Like, for example, medical anamnesis, right? Or chart reading for business for charts in the financial sector, you know, like the S&P 500, interpreting the S&P 500. Then they will train with hundreds of thousands of training tuples, and then they can reduce severely the rate of hallucinations. But you will never get a guarantee that everything is correct. But by doing what they did, they tried now to train a general purpose model, right, for general conversation. But if you license this model and have the money to train it for a specific domain, it will become very impressive. So I think that it will be able to support physicians in the differential diagnosis of all diseases. So it will get used a lot for this once the money is spent to specify it to a certain type of knowledge.
Thank you, Jobst. Okay, Jason, please share your question.
Wonderful presentation. Thank you so much. I thought I understood that there were some actually technological breakthroughs that enabled this current third generation of AI systems, not just scaling up of computer power. Could you describe what it is that's the new secret sauce, and if there's still going to be a place for good old-fashioned AI systems, either in opposition to or in synergy with?
So it's 11:15 in the evening here, but with such questions, I stay wide awake. Great question. So first of all, classical AI has a lot of applications still, because deterministic AI has to be used everywhere you want to have an absolutely secure outcome, like on the battlefield, right? So if you have the whole military AI contains a lot of stochastic elements, but the final decision for the targeting for a cruise missile, for example, is deterministic, which is old-fashioned AI. Then you have the same you have for defense systems and so on. Then stochastic AI in the classical sense, which are non-neural networks, but regression and classification they are the predominating models, because most companies don't have enough data to train neural networks. Neural networks are super greedy for data. You need billions of data points because they have so many parameters. So you get into what mathematicians call the curse of dimensionality, and to overcome it, you need then, you know, if you don't have so many data, you need to use the old models, and they will still be used for a long time, probably forever. Now, what were the great innovations that made this possible? So there are two lesser innovations, so to speak, which is that computer power was increasing and that there were more data in digital form available. This is kind of necessary but not sufficient. But sufficient conditions are the following. Schmidt-Huber invented the recurrent neural networks in the 1990s, a German genius, really. And with them, you could suddenly build deep neural networks, because you could now stack different modules of these recurrence, LSTM they were called, long-term, short-term memory neural networks on top of each other. And that made neural networks context sensitive, because now they could basically not only look at a short piece of input, but all of a very long stretches of input. And this you need to create language models, because language is, of course, highly contextual. So this was the first big innovation. And I can go on more, but just to make it a bit shorter so that others can ask questions as well. And then the superb innovation, where is it? I think I have the paper here. It's called Attention is All You Need. I don't have it. Attention, that was published by Google in 2017. And that was a paper that overcame the LSTMs, because the LSTMs are slow and they're very hard to calculate, and you need much more computational power. And Google invented something that is called Attention, which allows you to compute much more elegantly the context that LSTMs provide. And that was a breakthrough. And after this was published, came an avalanche of language models that led to what we are currently witnessing. But these are the big steps that were taken. And then the foundational models came. And when I saw the first foundational models, I said, gosh, this will really rock it. And it is true. But at the same time, we also should be aware that this is still just, a mathematical model. And no consciousness, no thinking of the model, no semantics. It doesn't know what it's doing, but it's still impressive what it can do.
Thank you so very much.
Thank you for your question, and thank you, Jobst. You can always expect those meteor questions from the Yale alumni audience. Lisa, please share your question.
Hi, thank you. So I have no background in any of this, so please excuse me if the questions sound at all ignorant. I'm wondering, in terms of getting the data, what the data is that AI operates on. Where does it come from? Is it from scraping internet websites? Is it knowing where the data comes from matters, because a lot of the data on the internet is inaccurate. So that's one question. And then I had a second question. If you could just go into more detail about what you mean by business intelligence, I would appreciate it.
So let's do the first one. So the initial huge data models were all created by uncritically scraping the internet. And so for the one that made neural networks famous was the one by Google that recognized that could create automatically an abstract version of the face of a cat. And what Google did, they used all the photos of cats they could find in the internet. That wasn't sufficient to train the model. So they had the idea, because they had bought YouTube, that they would use the movies made of cats, where people posted a video and said, this is a movie of my cat. And so because there are 24 pictures of the cat per second, suddenly they had enough pictures. And so then they had millions and hundreds of millions of pictures of cats and could now train the model. So this was the initial stuff. Then they used, just text scraped from the internet uncritically. That created Tai, a Nazi chatbot made by Microsoft. Because there was so much, adversarial language and hate language in the normal internet, that when you trained your machine on this, it became like this, I mean, humans are bad. It's in the Bible, and so the texts they write are bad. And if you just uncritically train on them, you get into problems. And so that's why Tai and other chatbots of the era before the foundational models had to be shut down. And now what OpenAI did is that they took a lot of effort to cleanse the data before they trained. So they really used filters using, deterministic keyword search and other instruments to clean the texts, so that they could basically avoid creating a distribution that contains all this negative content. But you can't succeed, because there are billions and billions of text of sentences that you're using. You cannot clean them out all. And that's why, for example, you can, if you're really clever, you can get ChatGPT to say that you should suicide yourself. Yeah, which is of course quite adversarial, I have to admit, right? And this it's actually worse than using, vulgar language. And and I mean, if you say this to a person, you might actually really motivate a suicide. So I think, and that's possible because it's not possible to clean all the language that's used for training. The same would be the case with pictures. And to your second question, BI means business intelligence. It's a very primitive form of arithmetics and basic mathematics and basic statistics to gain fundamental insights from your data. So what is the average age of my users? What is the average age of the new users? What are the demographics of the churn users who end the relationship to my company? How long does process step A, B, and C in a process take? Is if the worker group F worse than the worker group G, and so on and so on. So this is just basic analytics of business data. It's super important. It's the working horse of modern business consulting and improvement of businesses.
Yeah, this is Fred. I just wanted to comment on business intelligence. Anytime I can talk about BI, I'm happy to do it, because I was actually in the room with Howard Dresner, who's the self-professed father of BI at DEC, Digital Equipment Corporation. I was actually, I'm like the uncle of BI to Howard's father of BI, but a great question. So business intelligence is the analytics, it's transformation of data to information to intelligence, and ultimately for improved decision-making. We've come a very long way since, believe it or not, it was 1989. But I think there's a really exciting application of AI, particularly machine learning, to learn and build these algorithms and these applications and solutions that learn from the data and add incremental intelligence. And there's probably we could do a whole nother webinar, maybe we'll do that next, of the application of this. And ChatGPT is just one element of that, and generative AI in particular. I love the concept of taking what was primitive BI, which was heavily dependent on the human factor, the human form, and adding this notion of learning. And with this, we don't really talk as much about big data as we used to. So a great question, and Jobst, and thanks for your commentary and your insights there.
Yeah, I mean, just one more word on this. So you can, if you have BI, you can put AI on top of it and combine it, and that's super powerful. I've done it for some customers, for Daimler, and also for some pharma companies, and it's very impressive what you can do. And you really get kind of a human-machine hybrid system that can create enormous value if you set it up cleverly. Of course, there are also many traps, so you have to know what you're doing, but it's super powerful, and it's the future for all companies, I think.
Thank you. Avi.
One thing that comes to mind is you talked about words that cannot be said, and I suppose pictures that are considered pornographic, but that very quickly gets into the domain of the eye of the beholder, especially in the terms of pictures. I get the feeling that there's a group of humans somewhere behind closed doors making decisions as to what the ChatGPT can and cannot say, or can or cannot show. And so you wonder whether we're back to the back room where there are a handful of people controlling things. The second question I have is, I'm reminded back in the days when, UNIVAC was the first computer, and it took a room full of vacuum tubes, and now we hold a computer considerably more powerful in the palm of our hands. And I wonder if that's the future of AI. It's got flaws now, but they will be refined and perhaps be able to be shrunk down to the point where we'll be able to have this AI capability for each individual and in the palm of our hands, given a few years.
Yeah. So let's start with the first point. So what OpenAI has done, they have indeed they've tried to teach the computer what they think is political correctness. Why are they doing this? I mean, I don't know people working there, but I know people at Google, and many of them are personally not politically correct at all, right? But the company does this because they're afraid of the cultural context. They're afraid that their machine might say something that is being regarded as incorrect and that this will harm their business. Now, so the primary motive why this is happening is a larger cultural context. Are there people in backrooms figuring out what they should do as a company? Of course they are. Is this trend good for us and for, you know, free speech? I don't think so. What is real violence? Real violence is not words, but real violence is when people get, when your skin basically gets, you know, pierced. That's when real violence starts. When your body is subjected to pain. That's not happening here. So I think we have a bit of hysteria here on the one hand, but on the other hand, corporations always go with the cultural context. And so that's what we're witnessing. They don't create the cultural context, they just go with it. So much to your first question. The second question, so already now you can have AI in the palm of your hand, because although the large language models are much too large to fit on a computer, you can, of course, tell Google, find the way to there, and then your voice recording is sent to a server on which a model resides. It can compute an answer to your request and send it back to a mobile phone. This will stay like this for quite a while, because those models are extremely big, and they will not for a long time not fit in the palm of your hand, but because of electromagnetic waves, this doesn't really matter. So you can still get the answers you want onto this small handheld computer that you can carry around with you, though the models have to reside on huge machines.
Thank you. And Robert.
Thank you. Is the day coming when AI can predict crimes that are about to happen or do our tax returns for us?
So this, I think that it doing the tax returns is actually absolutely, unless you have a super complicated setup. If you have a regular setup, yes, that will happen relatively soon. I think it could be happening so soon that you and I, who are already of the older generation, will still witness it. But with the first question, predict crime. So this is super interesting. I don't think so, and why not? So I wrote a book together with my friend Barry Smith called "Why Machines Will Never Rule the World." It's about the mathematical limits of artificial intelligence. It's a theory of science book, and it describes why we cannot do certain things with the machines. And the reason is that human beings are complex systems, so their behavior is thermodynamically speaking very complicated, and there are many criteria with which you can explain what that means. But what it means ultimately is that you cannot predict the behavior of human being very well. For example, suicidality. A psychiatrist speaking to a depressed person has a chance of 8% of correctly predicting a suicide, and a chance of 25% of predicting self-harm behavior. So it's very, our abilities are very low. And if you use machines to do this, it doesn't get any better. And that's because complex systems are so hard to predict. That's what makes life interesting, but what also makes, creates quite massive restrictions on what computers can do. And so all those wet dreams that you find in Nick Bostrom or Klaus Schwab or Elon Musk about what we will soon be able to do with computers, I think are a reflection of their lack of knowledge of the theory of complex systems and the limitations of what can be mathematically achieved.
Thank you.
So Jobst, are you saying that we're not going to see a Skynet or the equivalent in the near term or medium term gaining consciousness and taking control of humanity?
Yes.
Is there a downside to any of this, or what are some of the risks that need to be mitigated and managed? And I was actually thinking, is there some equivalent of like the AI rules of robotics that, if you're a fan of science fiction, we saw with that movie starring Will Smith?
Yeah, so that's Asimov's famous series, I, Robot, great book. I can recommend it to everyone. I read it as a teenager, but it's still cool. So Skynet and other ideas of the so-called superintelligence, I think will not arise, because not in the short and medium term, but I would even say in the book we say never. Why do we say never? Because I think to build such machines, you would have to first understand how consciousness, the will, and intelligence work. And I think that these are so complex in nature that we cannot create mathematical models for their function. The book has many pages about this and gives a lot of details into which I can't go now, but I think it's very, very unlikely that we can create mathematical models of consciousness or intelligence. And if we can't do that, then we don't have to be afraid of AI overlords or however they are called. However, your second question was very, very good. What are the downsides and the dangers of AI? Now, this is like with all technologies can be used for good purpose, but they can be abused. And if you think about, for example, social credit systems that are now introduced in China, they really use AI. The face recognition they use, and also the voice recognition, which also allows you to identify an individual perfectly, even if you don't have a picture. They are already used in China to pin down who is doing what. And then you can use some basic algorithms that don't work very well, but to kind of try to understand what the individual is doing. Then you can start to do a perfect mass surveillance system. And I think this is, we are all, members of a free society. I've always admired America for its, freedom tradition, and such technologies can be abused for social control in a very bad way. I think they are unconstitutional given the US Constitution, and they are not compatible with our view of natural law and also, common law, which is also the foundation of the US system. And so I think that this is one of the dangers, that AI can be abused for such purposes, for domination, essentially. And of course, the AI doesn't then do it, but the humans who use the AI, like a hammer, you can use a hammer as a tool, but you can also use it to kill someone. And basically, this danger is also visible with AI. And we need as free societies, we need to fight that this will not happen. And there are many, many applications, like with digital currencies and many others, where it can be abused in a quite bad way. And so we have to be aware of this, and we as citizens have to stand up against this, I think.
Yes, Alex.
Another question, but from me this time. Professor, you mentioned that the reason ultimately that you think that AI won't sort of achieve these apocalyptic scenarios of superintelligence that can't be controlled and does unmitigated harm is because really anything approaching a human consciousness would be so complex as to really defy any possible mathematical model. I guess my question is, it seems that in the past we might have had similar skepticism about the potential complexity that any system, institution, or even mechanism could have achieved, and yet we've blown very far past that. I sense that there's maybe more to this threshold that you think we can't really pass with this tool set than simply a matter of complexity. For example, our computational power, if we ever achieve quantum computing, will skyrocket. And so insofar as there are brute force problems, right, maybe we will suddenly be able to achieve more in that regard with similar similar processing power, just working a lot harder for us.
Yeah. So the core argument is that complex systems, the complex systems we've achieved in our societies, are always systems involving humans. And the systems which are fully automated, like look at, for example, the Niagara Falls electric plants, right? Which, okay, they need maintenance, but they are incredible engineering effort, which is super complicated, but they are still logic systems. And the logic system is a system that is deterministic, and that in which certain, basic laws of thermodynamics work in our favor. The same is with all electric circuits, everything that we've built, airplanes, everything that we've built that functions technically is a logic system. And complex systems have totally different properties. So, for example, if I take this bottle and pour myself a glass of water, then I have kinetic energy that comes from the difference in height from the bottle of water and the glass. But in the glass, it gets transformed into heat, and this process is mathematically not understood. And it's a very simple process that occurs everywhere in nature. It's called turbulence. It's also when the wind blows through snow, or when you smoke a cigar and they have the plume of the cigar and so on. And we have no mathematical model even for this simple turbulence phenomenon. And this is one of the simple phenomena of complex systems. They are much more complicated. And one of the great physicists of the 20th century, Heisenberg, said when he dies, he expects God to explain to him relativity, general relativity, but God will certainly fail to explain turbulence to me. And again, this is just one very simple example. And so I think the limitations of mathematics are very hard to see when you're not a mathematician. But if you work in mathematics like I've done now for 25 years, then you recognize that mathematical models are in the end logic, and that the reality, they can only model parts of the reality. So I'm not going to say something is totally impossible, but I just think it's very unlikely given the complexity of reality, and that for complex systems, we have very powerful partial models, like the effect of aspirin on the human body. We have very good models, or penicillin, right? We have very good partial models that let us use those tools very effectively, or insulin. There are many examples. But we don't have, a comprehensive understanding of complex phenomena. And I think that our culture has not yet, the general culture has not yet achieved consciousness about this. Whereas top leading theoreticians of science, they know this. This has not trickled down to our culture. And the reason why this isn't trickled down is that the success of science in the last 100 years has been so stunning that, everybody thinks it will always go on like this. But if you look at, what is really feasible from a perspective of physics, also particle physics, quantum physics, then you see very clearly the limitations of models in physics. And I think that this just needs to, gain more understanding in the general population. It will happen once the velocity of progress will start to decline. And we are already, if you talk to physicists, they already say that they see this decline, but it's not yet visible in the everyday life.
Please forgive me if you covered this. I stepped away for a minute, but did you read the New York Times article in which the author interviewed Bing, and Bing basically told him to leave his wife, that Sydney, as Bing was called, his wife doesn't really love him. What went wrong there? And do you have any idea whether that's something that could happen again?
Yeah, so what went wrong is that, as I said during the talk, you can't train a conversational automaton like ChatGPT or Bing for conversation, because in the training step that you perform, which I showed, you can only do one iteration of question and answer, because afterwards you have a combinatorial explosion, right? So if you do more than one question answer, you have then suddenly, more combinations than there are stars in the universe. And because of this, because of the huge variance of human conversation, you can't train dialogue. So therefore, what happens when you try to do a dialogue with such a machine? Now, if you have a piece of text and an answer, question, answer, then the whole stack is taken and given back as one to the model, to give the model the context that I described, this LSTM-like context, that the model is aware of what was said before. But when you do this, you suddenly trigger behavior of the model that you cannot control up front, because in the training situation, you never can get those combinations fixed. And because of this explosion of combinations, then the model starts to do things that you can't control. And that's the explanation. And I think I have to write a paper about this. I think nobody has recognized that that's the reason it's happening. And now I think that when the tech giants will realize this, they will just limit the number of iterations that can happen in a conversation. Because what you do when you do this in a clever way, you can dig out really evil stuff of the models. Because as I said a bit earlier, there is a lot of evil stuff on the internet. Even if you clean the contents, there still remains a lot. And so then you can, another situation, the model told the user to commit suicide, which is even worse than leaving your wife, And so that's because of this an inability to control. And so it will happen again, but the tech giants will just restrict the number of iterations you can have in a conversation.
Thank you.
And John.
Yeah, question for you. Are there concerns or efforts to ensure that the integrity of the computation and the data do not become corrupted by third parties who have malicious intentions?
So this is a very good question about the intersection of cybersecurity and such machine learning models. So basically, until now, though there are ways to fool the models, they are called adversarial attacks. So you can show pictures to models that that irritate them. I can't go into how this works now. This has not been such a big concern yet because the models haven't been deployed in a naked fashion to public usage so much. But of course, when they get deployed more, people will attack them. And if they can manage to inject toxic contents into self-training models, they can break them. So that's what happened to Tai, the chatbot by Microsoft 5 or 6 years ago, because Tai was using the dialogues that it had with the users to retrain itself, it became toxic. And so there are ways to hack the models either if you abuse their retraining, which would also happen if millions of users would click all the emails they get as normal emails as spam emails, the spam filters would break, right? And so that's because of the retraining mechanism. But if you don't have retraining, you can also do malicious attacks on models like the New York Times journalist did, by basically injecting content into the model that makes it create toxic output. So, and we will see much more of this. And so this is also a big problem, this vulnerability. And I think there's a risk if such models are put into mission critical production in a careless way or not thought through way. Like you can also do mass attacks on cars, right? So if the same model would be built into a car fleet and you would hijack this car fleet, then the cars could misbehave. So this is potentially very dangerous. And we are still only at the beginning of answering the question, how can we protect the machine learning models? And the reason why we have not put so much effort into is that in the real world, they don't get used yet so much. But once they will, we really have to put a lot of effort into this.
Great. Thank you, Jobst and Lisa. I will get to you right after Will.
Sure. A couple of things, but one thing I will mention, I think one of the problems with framing this is that the base term AI is fundamentally a misnomer because there's not intelligence. So instead of calling this like the super smart word processor, which sort of gives us a more bounded view of what it's capable of, we think intelligence, we think thinking, we think cognition. And, if anything, this whole session should disabuse you that this is anything but literally really good math that says statistically, this should be the next word. So, but I think from a business strategist, how can I make money on this technology? Because I wrote CNNs a long time ago. And as was really mentioned briefly on a slide, we don't know mathematically really how these work, but they do, and we can apply them to a lot of things like business intelligence and get hardcore value. But the preamble here is just the punchline, and that is there are a huge number of IP issues that are unresolved, specifically about training data and generative AI. One right now is Getty saying, you scraped our images for your generative AI model. Those were copyright data. You owe us money. And that sort of makes business sense because copyright. So if you extend that to ChatGPT and you say, you scraped all those copyright websites, you owe me money because now you're making money. What does that mean for the future and application of LLMs?
So let's start with your first comment. So I think AI is a marketing term that was invented to get research funding for computer science departments. I myself wrote grant proposals to get this kind of money. And though I always put a footnote, because I wanted to be honest, but I couldn't agree more with you that I've trained my first models in the 1990s, so I know what I'm talking about. But But yes, I couldn't agree more with you that it's a misnomer. There is no artificial intelligence. It's just applied mathematics, right? And so people should always, and people like Musk who believe in the singularity, the super intelligence, they don't understand what they're doing, you know, because they are just doing marketing stuff. But they, even Ray Kurzweil is totally wrong, and that's because they have if you once had a course in function analysis, then you know that this is nonsense, right? You just need one, and I don't know how many of you have studied math, but those who did, function analysis is a wonderful field. I can recommend it to everyone. And then you understand this. Now to your second point, the IP issue. Yes, this is a super clever and important point. It plays no role for many small AI models which are trained by companies on their own data. Like all the models I do for my customers, they are all based on their own data, so there is no problem there. Or on public domain data where it's okay to use them as training material, like Wikipedia. You can, you know, if you under certain conditions, you can use it. But if you really use copyrighted material, then you have a problem. And I think that because the copyright is so critical for many industries, they can't give it up. And so therefore that will be enforced, and that will also impact a lot of what's happening. And some people, and we haven't discussed it yet, propose that this can be solved with synthetic data. I totally disagree, because when you create synthetic data with computers and then you train a model, then you just create a reverse functional of the training functional. So I'm talking now to you as a mathematician, right? So you know what I mean with the reverse functional. And so it doesn't work. And therefore you need original data. So otherwise you don't get the right distributions, and the IP issues will come back and bite those who have disregarded them. That's a very, very important point. Thank you.
Thank you so much, Will. And Lisa. And before Lisa unmutes for her question, I'll give her a second. I shared an article that is from the Pontifical Academy for Life, which is sort of a think tank of sorts out of the Vatican. And it came out maybe 2 or 3 years ago. And there's an interesting discussion that really addresses this whole question of the misnomer with the term intelligence. And it's true. It really is from the get-go. It's kind of baked in that there's this misunderstanding of what this technology is capable of, or to what it can fairly be compared. So Lisa, please share your question.
So I want to build on Will's last point about intellectual property. I am wondering, not just with AI, but with a lot of uses of data. You know, Google's using our data for targeting advertising towards us. Cameras capturing our faces as we walk around in our environments. I want to raise the issue of whether there is some data that should be owned by society and totally open and should not be able to be private. Like, for example, I have a problem with patenting biological material. You know, I don't think companies should be able to patent biological material, because that is, even if they are creating unusual materials, it's all derived from nature. Similarly, if companies are benefiting from the data that is provided by millions and billions of individuals, why did they get to own it? And I'm wondering if this issue has come up at all in the field of AI, and if so, what's happened with it?
So on the first point about biological molecules, I could talk a lot, but it's not the right place here, but we can have an email exchange on this, Lisa. It's a very important question with which I've dealt when consulting for the pharma industry a lot. But to your second point, of course, this question of who owns the data that Google collects, there has been a lot of legal thought and also, you know, legal battles. And the end user licensing agreement that you sign when you agree to use Google, they give Google the rights on the stuff that you use, on the questions you're asking, and so on. So basically now with Facebook, Google, and the other social media giants, they've made sure that in the existing legal framework, they're allowed to use this data. Is this right? Maybe not, but at the moment, as things stand, they can do it. But they can't do it if you don't give you agreement. And so that's why some people are de-Googleizing themselves. They are getting rid of Google on their phones. They're not using it on the internet anymore, and so on. But it's a very important question, and it's especially problematic if you think of the ownership structures of who owns the tech giants, you know, and who owns the big shares, and then you get down to very few families who have a lot of power.
Well, I just want to raise one other point connected to this, that as these companies become more and more dominant, they have more and more control over our lives, so that just de-Googleizing yourself or refusing to use their services becomes untenable. And the specific example I would give with that is, I live in Boston, Massachusetts, where Mass General Brigham is one of the dominant healthcare networks. And when I go to one of their hospitals, I am asked to sign a legal agreement that says they can use my biological materials. In other words, anything that comes out of my body, that it becomes their property. Every time I go for any kind of medical anything, I cross all that out, but I'm not going to be able to get away with that forever. That's the kind of thing I'm talking about. It becomes so pervasive that individuals can't fight it. And then I'm done.
Thank you for those questions. I think that there are probably so many other questions and aspects of this issue we could address. We really appreciate your time. And Fred, I'll turn that over to you.
Well, I'd like to say, first of all, thanks to my newest best friend in the Yale Club and Yale Network, Kevin, for all of his tremendous work. Again, thanks to Jobst for being our speaker. Thanks for Alexander for some not only great introduction, but some really great question, and everyone who asked the questions along the way. I think this was a really, really tremendous virtual event. So thanks to everyone today for joining.